This video presents the concept evaluation report for Group 4, composed of Nader Abdullahi, Tannyr Pasvantis, Zandy Rizzo, and Keenan Witsken. This video will begin with a project overview, move to planning report conclusions, and then it will go through the introduction, selected system, concept alternatives, concept evaluation, and end with conclusions. The objective of the design project is to design and produce a machine which will outperform opponents and win the competition. Each round of the competition will be conducted in the arena shown here. There will be 4 machines, each beginning in the starting zone of each individual zone. In order to win the competition, our machine must earn as many points as possible in each round of the competition while defending against other machines. The function tree shown here identifies the main functional requirements of the device which present opportunities to earn points. Additionally, a house of quality was constructed to identify customer and engineering requirements. A planning analysis was conducted to identify major design considerations. It was determined that our machine's design must focus on maximizing points earned in each round, defeating opponents, and abiding by the rules of the competition. Because there are limited power sources available, a thorough analysis was conducted to determine the relative weight of each functional requirement and its correlating point return. It was then determined that it is most beneficial to eliminate one of the original functional requirements which has less significant effect on the machine's overall performance. This updated function tree is shown here. A morphological chart was used to identify the mechanisms which could be used to accomplish the functional tasks from the function tree. The subsystem morphological chart, shown here, then goes on to show the specific design choices which most appropriately satisfy the subsystem goals. Each design choice was taken from the morphological chart and then applied to one of the 3 functional requirements identified for our machine. The assembled integrated system, currently under development, involves the most effective design concepts identified. To elevate the golf ball, this machine employs a spring-loaded arm that unfolds upwards. This mechanism, shown here, utilizes a mousetrap to separate 2 long segments of wood. The wooden segments are lightweight but strong enough to support the golf ball at their highest reaching point. This design was selected because it addresses the top-rated engineering requirement from the House of Quality, reach height, as well as a highly ranked customer requirement, storage volume. This design is compact before it's extended and can operate from any location of the base. To force the Kong toy egress from the zone, this design captures the power and momentum from the drawer slide arm to push the Kong toy from the zone using the plow attached at its end. Additionally, this plow remains in place afterwards, preventing competitors from forcing it back into the zone. The plow's contoured shape defends against competitors who may attempt to push the Kong toy into the zone by flipping or lifting the Kong itself. It is essential that this task be accomplished quickly as the machine's design is oriented to reach the Kong toys in their initial location in the arena. Thus, it is vital to reach and remove the Kong toy before competitors have the chance to. This design utilizes a flattening arm and reverse plow to collect the ping pong balls. The flattening arm extends further than the ping pong balls and then retracts, pulling the balls into the zone. This design was selected as it is sturdy and unlikely to be broken by other machines. The location of the ping pong balls is likely to be visited by other machines attempting to collect the ping pong balls and force the Kong toy into the zone. A sturdy mechanism is necessary to provide reliable use in every round of the competition. The assembled integrated system is shown here. Initial testing results for the individual system of elevating the golf balls shows promise. The spring-loaded arm connected to only 2 wood segments triggered every attempt, performed consistently, and recorded a height of 44.5 inches above the arena floor. This score was ranked 2nd out of the 5 teams in the studio session. As such, it will be necessary to modify this prototype to reach greater heights and outperform competitors. Another system employing a flattening arm without a plow was tested and received a maximum score of 0, 0 being highest, extending to -78. This design also successfully triggered each time. The final subsystem to retrieve the ping pong balls is currently under development. Concept 2, shown here, elevates the golf ball using a pulley system. It expels the Kong toy from the zone using flattening arms and collects ping pong balls using the reverse plow similar to the selected design. Concept 3 employs an inflatable tube and blower to elevate the golf ball, expels the Kong toy using ramps and battering rams, and collects only half of the ping pong balls using a net attached to one of the battering rams. This was used because there was not enough space in the starting zone to include a net on both battering rams. Concept 4 uses a telescoping pole powered by strings attached to a DC motor to elevate the golf ball. It expels the Kong toy using scissor arms powered by a gravity-powered 2-direction scissor arm system, and it collects the ping pong balls by spring-loaded extension arms attached to the collection head. An evaluation matrix was tabulated to evaluate each concept's performance weighted against the importance rating that the criteria customer requirement received in the House of Quality. The criteria which received a weight of 10 out of 10 are mandatory as their completion is associated with qualification to compete in the competition. As such, every design received a 2 or satisfactory rating on these categories. The selected design received a relative total of 0.3, trailed most closely by concepts 2 and 4, which both scored a relative total of 0.25. The specific areas where the selected design outperforms concepts 2 and 4 are now highlighted. This performance disparity is due to the subsystem mechanisms which are better suited to accomplish the tasks incorporated in the selected design. The selected system focuses on maximizing points earned, defeating opposing teams, and a high completion rate of a smaller number of functional requirements. Preliminary testing has yielded the predicted rates of success and supplies vital information for prototype modification.